So yesterday we introduced the idea of the mole. Okay, the mole is a specific amount of particles of any material. Remember that specific amount, not in the big writing, is 6.02 times 10 to the 23 particles. Be those particles atoms or molecules, that depends on whether you're dealing with an element or a compound. Okay, whose number is this? What's that?
Avogadro's or something?
That's close, yeah. This is Avogadro's number. Okay, Avogadro's number is the number of particles in a mole. You may, right? We did the first two types of mole equation problems yesterday in class. Okay, the last two types involve using Avogadro's number. Avogadro's number is required in two situations. If the question asks you to calculate the number of particles in a sample size, or if the question gives you the number of particles and asks you to calculate the mass of that many particles. In both of those situations, you will require Avogadro's number. All you ever do with Avogadro's number is either multiply by it or divide by it. That's all you ever have to do with it. Okay? So let's say a question asks me to calculate the number of particles in 12 moles. Okay? So number of particles in 12 moles. How would I do that? Exactly. This is the number of particles in how many moles? 1. So if I want to know the number of particles in 12 moles, I just multiply the number of moles by Avogadro's number. Okay? In the same way that if I asked you, I went out and bought 2 dozen donuts. How many donuts do I have? Well, I bought 2 dozen, guys. 24. Right. Everyone's like, knee-jerk reaction. Okay. Yeah, I bought 2 dozen, I have 24 donuts. How did you do that? Yes, math. What math specifically?
Dozen is 12.
Right, you multiplied the number in a dozen by the number of dozen, I told you, 2. Well, initially 1, but 2 after that. Okay? Everyone okay with that idea? All right, now, what if I was to ask you, I have 36 eggs. How many dozen do I have?
3.
How'd you do that? You divided by the number in a dozen. So if I told you I have, 7.5 times 10 to the 26 particles, how many moles do I have? You would take that number and divide by Avogadro's number. Okay? All you're ever going to do with that number is multiply by it to get the number of particles, or divide by it to get the number of moles. Okay? That's all it ever does. Okay? So it kind of sets up like this. The number of moles equals the number of particles divided by Av's number. Okay, that formula is not on your formula sheet because it doesn't need to be. Okay, as long as you understand the whole thing with the 2 examples with the dozens that I just did, you can do this. Okay, it's the same idea. Okay. So the questions we're going to work on are still going to involve using the mole equation, n equals little m over big M, but they're going to have an additional step involving Avogadro's number. Sometimes that's the first step, and sometimes it's the last step. It depends on whether it's asking for the number of particles or giving you the number of particles. Okay? Let's look at our first example of an Avogadro number question. How many molecules are in 600 grams of silver nitrate? Okay, so write this one down, I'll give you a sec, and then we'll go through it. Okay. First step in solving any problem is to write down the givens. Okay, so in this one, they're asking me to calculate how many molecules. So okay, number of molecules is my question mark. Are in 600 grams. What did they give me there? mass, which is what part of the mole equation? Little m, right. Okay, of silver nitrate. What is that going to help me get?
Big M.
Big M, right, the molar mass. All right, but what do I have to do before I can get that? They told me silver nitrate in words. What do I need? I need the formula, otherwise I don't know how many oxygens and nitrogens and whatever are in there. Okay, so silver nitrate, Ag, all right, that's a +1. Nitrate, NO3, that's a -1. So that compound is fine without any other numbers. Okay, so silver is 107.87. Okay, and there's only one of it. How many nitrogens are there? One. 14.01. Okay, how many oxygens are there? 3. 16 times 3 is 48. Okay, so, oh, I forgot to start up my calculator. Wake up the hamster, it's not turning the wheel yet. Okay, so we got 107.8, whoa, 107, not 17, 107.87, and plus 14.01, that's my nitrogen, plus my 3 oxygens, 48, is going to give me 169.88 grams per mole. Okay, so I've got little m and I've got big M. What can I find with those two numbers? Number of moles. Will that help me get the number of molecules? Yes, it will. Okay, so my first step is to use the mole equation as it is already written, solving for number of moles, or N. So I plug in my numbers here, 600 grams. Okay, and I divide that by the molar mass, 169.88. Like 3.83 or something like that. Not that, 600 divided by the answer. Okay. 3.5. Okay. All right, should I keep all those decimals in my calculator? I should. Okay. The reason is this. If I round this number off and then multiply by a gargantuan number like Avogadro's number, am I rounding off a significant number of other numbers?
Yeah.
Do those other numbers represent lots and lots of particles?
Yeah.
Yes. So keep all the decimals in your calculator until the very end. Then you can round down to 2 decimal places. Okay? All right, so I've got my number of moles. Now what do? I'm looking for a number of molecules.
Times by Avogadro's.
Multiply by Avogadro's number. Okay, remember, this is how many moles I have, and this is how many molecules are in 1 mole. So if I multiply the number of moles I have by the number of molecules in a mole, I get the number of molecules. Are you okay with that? Okay, same as the calculation we did when I told you I have 2 dozen donuts. How many donuts do I have? 2 times 12. Okay, now we're going 2 times 6.02 times 10 to the 23. Okay, at this point people are like, how in the heck do I put that into my calculator? It's a good question because it's in scientific notation. How many people have done scientific notation before? Okay, so a few of you. So scientific notation is a way for us to represent really, really big numbers or really, really small numbers more reasonably. Okay, by simply taking advantage of the fact that our numbering system works on the base of 10. Right, so you got like your 1's position, your 10's position, your 100's position. Every time you move, you're moving by a factor of 10. Everyone follow me there? Okay. So all we're doing when we say 10 to the 23 is move this decimal place 23 spots and you've got the real number. Okay, now obviously 10 to the 23 means the number gets bigger, so I would move the decimal to the right. Okay, if it was 10 to the minus 12, I would move it to the left because that would be a very small number. All right, so I'm going to punch that into my calculator. Here's how that's going to look. So I'm going to take that number there, just go times, so it keeps the number, and then I'm going to use brackets. In brackets, 6.02. Then I'm going to hit the second function button, and the comma. Above the comma are two capital E's. Okay, so it gives me this capital E. Oddly, the button shows two capital E's, but only puts one in there. Okay, what that capital E means is this number is multiplied by 10, and the next number you put in is the power of 10. Okay, so what number am I putting in after the E? 23. Okay, so that's how you put it in if you've got one of the TI calculators. If you have another type of calculator, you may have a button that looks like this. EXP. Okay, if your calculator has an EXP button, that's the button you would press instead of the EE button. All right. You may also have just an EE button. Okay, some calculators. I think the iPhone, if you're using the one in the iPhone, I'm pretty sure it uses an EE. Okay. So just have a look for those. Those are basically your two options. All right. What I don't want you to do is type it in like times 10 and then use the hat thing, because I find people mess that one up all the time. Right? Now, it is crucial, guys, that when you put it in any type of calculator, that it is enclosed in brackets. Okay, so that it's one number, and whatever you're multiplying it by gets multiplied by the whole number. Otherwise, it could go multiply by 6.02 and then do the next thing, and people mess that up. Okay, so make sure you put it in brackets so that it's enclosed. Any number in scientific notation should always be enclosed in brackets on a calculator. Okay? Otherwise, your calculator tries to do order of operations, and it messes things up really bad. All right, so I've got my 3.53 multiplying it by Avogadro's number, and this is what I get. Well, we'll round to 2 decimal places. 2.13 times 10 to the 24. Okay, so that's my E24, so it's times 10 to the power of 24. All right, so the number of molecules in this one here is going to be, sorry, I forgot the number now, 2.13. Times 10 to the 24 molecules. Okay, so it's got one extra step. So a question like this would probably be a 4-mark question. You would get a mark for your givens. You would get a mark for calculating the number of moles. You would get a mark for calculating here, for using Avogadro's number, and a mark for your final answer. Okay, so for 4 marks. Okay. Questions on that one? All right, we got one more type. It'll be at 5. Because you actually have to do algebra with the mole equation in that. Okay? So in this one, the question gives me the number of particles and asks for the mass. All right? So it's the 4th type. 4 of 4. And there's only 4 ways for me to ask these. All right, so in this type of question, we still start out the same way. We write out our givens. All right, so our givens are the number of molecules. Okay, 1.54 times 10 to the 25. Okay, so does that mean I have more than a mole?
Yes.
Yes, significantly more than a mole. Okay, a mole is 6.02 times 10 to the 23. This is times 10 to the 25. That's 2 factors of 10 larger. Okay, so that's a lot. This is a lot of 10s. Okay. So I've got that for number of molecules, and they tell me it is diphosphorus tetraiodide, which can help me get big M. All right, so diphosphorus means how many phosphorus? 2. Okay, tetraiodide means how many iodides? 4. Do I reduce that?
No.
No, it's molecular. It gave me the prefixes, that's the number. Okay, this one, remember, is not about dropping and swapping or charge balancing. They're sharing the electrons. Okay, so for phosphorus, we got 30.97 times 2 plus iodine, 129? 26.9. 126.9 times 4. Okay, 569.54. Grams per mole. All right, question wants to know what the mass is. So I'm looking for little m. If I want to get little m, what do I need? Little n, yeah. I have big M, I just calculated that, but I don't have n, I don't have the number of moles. But I have the number of molecules. And I have Avogadro's number, which tells me the number of molecules in 1 mole. So if I know those two numbers, can I calculate the number of moles?
Yes.
Yes, by doing what? Right, this number divided by Avogadro's number. Okay, here's the number of molecules I have divided by the number of molecules per mole. Molecules cancel, I'm left with moles. Okay, and it's just like saying I have 36 eggs. How many dozen do I have? 36 divided by 12, I have 3 dozen. Okay, works the same way. So to calculate the number of moles, I take the number of molecules, 1.54 times 10 to the 25, and I divide that by Avogadro's number, the number of molecules in 1 mole. Okay, now when I do that operation in my calculator, everything needs to be enclosed in brackets. 1.54 E25 divided by, in brackets, 6.02 E23. Okay, so I've got 25.58 moles.
Can you help me find that button on my calculator? I'm struggling.
That's that one, except that's different. I think I've seen that one before.
Okay.
Yeah, use that one in place of that. Okay, 25.58 moles. Do I keep all those decimals? In my calculator, yes. I'm going to be lazy and not write them all down on the board. Okay? All right, so that's going to be moles. All right, now I have N and I have big M. Can I get little m now? Do I have to manipulate the mole equation though? I do. Okay, so you got 1 mark here for your givens. You got 1 mark for calculating the number of moles. Now we've got to manipulate the mole equation to get little m. So that means we multiply both sides by big M. Okay, and then we plug in our numbers. 569.54 times 25.58. Okay, so you would get a mark for that step. Okay, so we're up to 3. Okay, and sorry, you get a mark for your algebra, a mark for plugging in the numbers, and then our final answer. So times that number. Okay, is that a lot? 14,569.627 grams is 14.5 kilos of that stuff. Okay, it's like 30 pounds, okay, of that material. It's a lot, but it was 25 moles. It's a lot of stuff. Okay, so we would write in 14,569.63. grams. 5th and final one. Okay?
Getting 14.
Yeah? All right, questions on that one? All right. How many ways can I ask a mole equation question? 4. That's it. You've seen all 4 now. All right, and what we're going to do here for the next few days is I'm going to put, each day I'll start out with 4 examples, 1 of each of the type, okay, to review how they work. Okay, you guys will get some time to practice that, all right, and then we'll start looking at a unit exam review next week, like a formal in-class one, but I'll put the package on Google Classroom probably Friday. So you can start having a look at that. Okay. All right, so for our first one here, we're looking for how many moles of carbon dioxide are in 150 grams. So our givens are as follows. I'm looking for the number of moles, N, okay? And I know that it is carbon dioxide, so that's CO2, which is gonna be 12.01 plus 16 times 2, 32, okay? It's gonna give me 44.01 grams per mole for a molar mass. Okay, and they tell me the mass of the CO2 is 150 grams. Okay, so I got 1 mark for my givens. I'm looking for N using the mole equation. That means I don't need to do anything with the mole equation. It's already set up to solve for N. I just have to put numbers in it. Okay, those numbers are going to be 150 grams for the mass on the top. Okay, and the 44.01 grams per mole on the bottom for the molar mass. Right, when I divide those two things, 150 divided by 44.01. Okay, we're looking at 3.41 moles. Okay, is that the easiest one? Yes, it is. Question?
If you write like the formula, like N equals a small m over a big N, or can you just write the numbers?
It's always best to show all your work. You get marks for it, so it's best to show it. Just especially in case maybe you mess something up with this, okay? Then I know, well, they knew the formula, they get marked for that, right? And then they get a mark for the answer because this is a 3-marker, right? So guys, yeah, when in doubt, show your work. If you're not in doubt, show your work. Always show your work. Okay, you get marks for showing your work right up until the diploma exam where Alberta Learning decides they know better. Don't give you marks for that. But okay, we think it's important. We think your steps are important, so we give you marks for them. And I wouldn't want for this to happen to you. Okay, I had a kid in my physics class, and he never showed his work. Never. Didn't matter how many times I showed him. Told him, gotta show your work, gotta show your work. He was smart. He got things right most of the time. But on the final exam, somebody comes around and clears your calculator. And he didn't set his calculator back into degree mode. And he didn't show his work. And the calculator spit out all the wrong answers for him because it was not in the right mode to do the calculations he needed. Without any work, all he had were 12 numbers that were wrong. The guy who should have got 85 on final exam failed his final exam because I couldn't give him any part marks because the only thing he wrote down was a number that was wrong. Yikes, that sucks. Okay, so show your work is the moral of the story. Okay. It's a boring story, but it has good moral. How many people are done number 2? Okay, let's look at number 2. All right, so for number 2 here, we're looking for the mass. So that means we're looking for a little m, okay, of 26.5 moles. So that's N. Okay, of cobalt-2 bromide. All right, so that'll help me get capital M. Cobalt with the 2+ charge, because that's what the Roman numeral tells me, with bromine, which is a -1, so we drop and swap, we get COBr2, and now we can do our calculating. Cobalt's 58.93, and there's only 1 cobalt plus 2 bromines, 79.9 each. So 58.93 plus 79.9 times 2, all right, gives me 218.73. grams per mole. Okay, so givens. Now, I know it's a mole equation question, so I know I'm going to be using this formula at some point. However, I'm supposed to be calculating what part of it? Little m. So what do I have to do with big M? Get rid of it. Well, not get rid of it, so much as move it over to the other side. Right? Okay, so I'm going to multiply both sides by big M. Okay, get a mark for doing my algebra, and plug in my numbers. So big M was 218.73 multiplied by 26.5 moles to get little m. So 5,796.35. And that will be, what are my units for that? Grams. Okay. Everybody all right with that one? Okay, I'm gonna give you a few minutes before we do number 3. You catch it. Okay, so on number 3, the question's asking how many molecules? Is this gonna be one of the ones where we need Avogadro's number?
Yes.
It is. Okay, so it's looking for the number of molecules, so that is our question mark in our givens. Okay, it's sodium sulfide, so that'll help me with M. Okay, Na with S. This is a -2 and this is a +1, so we're looking at Na2S. That'll be 22.99 times 2 plus 32.07. Okay, for the single sulfur atom that we have there. Okay, so 22.99 times 2 plus 32.07. And 78.05 grams per mole for our molar mass. Okay, and they tell me I have 29 grams, which is which variable? Little m. All right. If I want to get the number of molecules, what do I need first? Moles, yeah, I need the number of moles, which is right now the only thing I can calculate anyway. I have big M and I have little m. So if you're ever lost, like if you're ever looking at a question like this, and you're like, I don't know how to get that, but I can get N right now, then get that. It's the next step, and even if you don't remember that that's the next step, you're gonna get marks for it because it is the next step. Do whatever it is you can do, okay, if you get stuck. So N equals little m over big M. And that's going to mean taking our 29 grams and dividing it by 78.05. Do I have more than 1 mole or less than 1 mole here? Less. Yeah, if 1 mole has a mass of 78 and I only have 29 grams, it's okay if I get a decimal. I have less than 1 mole here. Okay? Sometimes getting that decimal throws people off. That's why I bring it up. 29 divided by that number. Okay, so I have 0.372 moles. All right, now that I know the number of moles, can I get the number of molecules? What do I do with Avogadro's number here?
Times it by that.
Multiply it by the number of moles, right? So number of molecules okay, equals N times Av's number. So that'll be 0.372 with all the decimals that are in my calculator, multiplied by 6.02 times 10 to the 23. All right, so that number right there, in brackets 6.02 B23. All right, 2.24 times 10 to the 23. Molecules. Okay, questions on the third one? Okay, once you know the steps for each of the 4 types, is it pretty straightforward? It's always the same step, right? Like type 1 is always the same step, type 2, type 3. How many people have done number 4? Okay, I'm gonna give you a couple more minutes on number 4 then before I go over it. Yep. Okay, so on number 4, we are looking for the mass, which is little m. Okay, and we know the number of molecules. Okay, 7.2 times 10 to the 23. Okay, and it is diphosphorus pentaoxide. Right, which will help me get the molar mass. So we will have 30.97 times 2 plus 16 times 5. Okay, so 141.94 grams per mole. All right, if I want to get little m, what do I need? N. All right, and I can calculate n if I know the number of particles and Avogadro's number. All right, so I would take my 7.2 times 10 to the 23 and divide it by 6.02 times 10 to the 23. Now, if you're like remembering something from math about exponents, since these are the same, do I need to bother putting them in? No, I can just go 7.2 divided by 6.02 because they have the same exponent. Okay, it's one of those little tricks. You can type the whole thing in if it makes you feel better. Okay, it'll still come out to the same answer. All right, so I will show it with everything in. So 7.2 E23, okay, divided by 6.02 E23. Not times, I want a dividing symbol in there. There. Okay, so I'm getting 1.196 moles. Okay, now I have N and I have big M. Can I get little m? I can, but I have to manipulate the mole equation because right now it solves for N. So I've got to multiply both sides by big M, which is the only manipulation of that formula you ever have to do. Okay, and solve for M by plugging in my numbers. So that will be 141.94, the molar mass, big M, times the number of moles, N, 1.196, and that will give me the mass of 7.2 times 10 to the 23 molecules of diphosphorus pentaoxide. So I will have 169.76 grams. Okay? How are we feeling about that?
Good.
Okay, it's just math, not that bad. Okay. So I'm gonna put one of the worksheets from the workbook up here on the board. It's gonna start out pretty basic, not even like as far along as these questions are. Okay, it's mostly like remembering the whole, how do I get moles versus how do I get number of molecules kind of thing. And then tomorrow we will start out with 4 examples, just like each 4. Okay, we'll start with the next day with 4 examples. And we'll do that until we're solid at it. Couple of things. So your unit exam is 2 weeks from tomorrow. And if you are struggling with anything in this unit, that's okay. But come and see me, okay, and get some help. Right? Don't struggle in vain. Okay? Come and see me and get some help. Usually it's something simple, okay, and we can go through it. What's the best way to study? Practice. Yeah, guys, the bulk of the marks on your unit exam are to do with reactions. Okay? Writing them, balancing them, predicting them, that's what the bulk of the marks on the test are about. Okay, so study that, practice that.
Will the reactions we're doing be any harder than the ones that we did for like the long assignment?
On the exam?
Yeah.
No, definitely not harder. Okay, maybe about the same. Okay, like I'll probably put 1 or 2. Like there's some, obviously I said there's some balancing in there, and there might be 1 or 2 that are tricky. And for the reactions, they'll be just like the ones we did in class. I'm not going to do anything other than the ones we did in class. Identify the type, balance. I'm not going to throw a curveball at you. Give you one like in the lab where I didn't even make you predict them because they were crazy. I'm not going gonna be, show me what I taught you. That's what's fair. Okay? And you'll get an idea of that when I put the practice test. Let's see what's on the test. Test I give you is just like that. Same level of English. Okay? Alrighty, so.
Where were they here?
Okay, I want you to do question number 1. It will take you maybe 3 minutes. 1. So how do I go about figuring out the number of particles? How many particles in 1 mole of gold? Right. Does it matter whether it's gold or like beryllium or iron? No, it'd be the same number, wouldn't it? Is that true for all of them? Okay. So 2.5 moles of helium atoms. So I go 2.5 times 6.02 times 10 to the 23. Is it the same for all of them? Yeah. Okay. 10 moles of hydrogen molecules. 10 times 6.02 times 10 to the 23, which would be 6.02 times 10 to the 24. Okay, 10 times bigger, right? All right, and then 0.628 moles of CO2 molecules, 0.628 times 6.02 times 10 to the 23. Okay, that's all you have to do to calculate the number of particles, is multiply the moles by Avogadro's number. That's all that question is telling you. And it doesn't make any difference what material is here, because Avogadro's number applies to everything. Okay. All right. So, be ready. We're going to do some more of that tomorrow. Okay? You want to hand in those, or have me look over those reactions assignments? Happy to do that. Come in at lunch, nighttime, or after school. Okay?
Those are due Friday, right?
Those are due. No, I changed the date. Oh, that's important. I changed the date on those reaction assignments. It was initially Friday, but I made it the 11th. That's the Wednesday after the Thanksgiving. Right? I thought, you know what, it's kind of big, maybe you want a little extra time. I don't know. Maybe I'm a softie, probably not.
It also means you don't have to mark most of them.
Well, and I already had something else to do that day, so